This is lesson 321, conditions for triangle similarity. So we're just trying to come up for what we need to guarantee about two triangles in order to guarantee that they're similar. So first off, if we have two shapes that are similar, what is true about their angles? So if we use tracing paper to figure this out, we would see that their corresponding angles are equal. Corresponding kind of means the ones that match or go together. Okay, so their corresponding angles are equal. And then they want us to find the stretch point for the triangles. Okay. Seems like this triangle right here has been doubled. If we took this side length, moved it over here, copied it, and put down another one. Looks like those have doubled. Okay. And it also looks like the triangles, the lengths have grown from each point. So we have doubled here. So if the angles in a triangle are equal, then they are guaranteed to be similar. Okay, this is just a true statement. If the angles are equal, the triangles are going to be similar. So let's check if the corresponding angles are equal here. So 87 and 87. Let's make sure that if we kind of rotated this triangle to look the same as this triangle, that would be correct. Let me just kind of redraw it so that it looks similar. So that means this would be E up here, G and F, 25, 87. Okay, all I did was kind of just rotate this triangle a little bit. Okay, yes, 87 corresponding. Now, we have two different angles. We have 68 and we have 25, okay? So what we could do to check to see if, for instance, E is also 68 like H, we could use the triangle angle theorem, which says that all the angles are supposed to add up to 180. So we should check 87 plus 25 plus, let's say, angle E. All those should add up to 180. And if we add up these two and subtract from both sides, we would get that E equals 68. Okay, which is the same as angle H. Okay, so yes, all of these angles are equal, which means the triangles are similar. So we could write a similarity statement. So we could say triangle JHI is similar to triangle, and now we have to make sure we match the angles. So the angle that matches with angle J, the 87, is G. And then next up, H, we just found that this was angle E, and then finally F. So it says how many pairs of angles need to be congruent to be sure that the triangles are similar. Now here's the thing, because we know that all three angles should add up to 180, we actually only need to know that two of the angles are congruent, right? Because if we have, let's just use this example over here. If we didn't know that this was 25, if we were only given that we have 68 and 87, 68 and 87, we are guaranteed that the remainder is 25. That final angle is 25 on both triangles because we know that a triangle should add up to 180. So we don't actually need to be presented with the information that all three are equal. We only need to know that two of them are equal, okay? So that is something that we call angle similarity. That's how we're gonna write it, okay? Angle similarity. And we would say this angle similarity. And it basically means that if we are given two triangles, oh, that is not a triangle. If we are given two triangles, let's say we have 18 and 36, 18 and 36, obviously not drawn to scale. If we are given that two of those angles are equal, that is enough to say that the triangles are similar, right? That's enough proof. So this these two triangles are similar by angle similarity. Going back to what we've talked about previously, okay, whoa, why didn't that go? We have been talking about how if the ratios of the sides are equal, then the triangles are similar. Okay, so I'm gonna kind of put a divider here because we're gonna end up having 3 conditions for similarity. We talked about previously that if all the sides were proportional, then the angles were similar. So for instance, if we have 2 triangles here, we should make one bigger, shouldn't we? Let's say that we have 3, 4, and 5. Let's say that they doubled, so 6, 8, and 10. If all the ratios of their sides, so 10 over 5, 6 over 3, 8 over 4, if all of those are equal, then those triangles are similar. So that is something that we call side, side, side similarity. Okay, side, side, side similarity. Which means that if we are given that all the sides of the triangle are proportionate, which means that the ratios of their sides are equal, that's enough information to say the triangles are congruent. Okay. And then there is a third one, okay, that we are going to call side angle side similarity. Okay, so if we had 2 triangles, it's a really bad example right there. You know what, let's copy and paste it and just make it bigger. I should have been doing this the entire time. Okay, so let's say 3, 6, and 12, and then 6, 12, and 12. Okay, the sides are proportional, right? They're both doubling. And then the angle is congruent, right? The angle is the same. That is enough information to say that triangles are similar, okay? Because the angle is the same, because the angle of these 2 lines are the same, that means that this third length right here has to be the same as well. So in a way, this leads us to say that we have side, 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 right? Because the angle is the same, we know that the side opposite of it is the same length. So that's why that's enough information to say that these triangles are similar. So this is side angle side similarity. Now, the important part is that the angle is in between the 2 sides so that we can guarantee that this third side is the same. Okay, let's say if the angle was over here, then that would technically be angle, side, and then side similarity. And that is not something that we want, or that would prove that these triangles are similar. Not only because it's a bad word, but also because it doesn't give us enough information, okay? So the angle has to be in between the 2 sides. Must be, I haven't used the word betwixt in a while. That's a fun word. That might be how you spell it, betwixt the 2 sides. Okay, so we're going to decide if these are similar. All right, so we have 32 and 32. We're given 2 different angles, so we should see if the missing angle would be the same. So let's use this triangle right here. 32 plus 96 plus a missing angle should add up to 180. So 32 plus 96 is 128. And then let's subtract that from 180. So that x equals 52. So our missing side is 52. And hey, that matches the 52 on the other triangle. So yes, these triangles are similar. All right, here, hopefully this might look like a side, 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 or side angle side situation. Okay, we know that the angles are equal, so we just need to check that the sides are proportional, that the ratio of their sides are equal. So let's do 44.8 divided by 14 and hope that it's equal to 64 divided by 20. So 44 divided by 14, or I'm sorry, 44.8 divided by 14 is 3.2. And then 64 divided by 20 is also 3.2. So because the ratio of their sides are equal and the angles are equal, yes, these triangles are similar due to side angle side similarity. All right, this triangle right here, now this one's kind of tricky because we do see that we have two angles that are the same. So because we don't have any sides, we'd be hoping that we have another pair of angles that are the same, right? I don't currently see any, but maybe we have to look a little bit harder. Okay, we have this first triangle, this is the big one. And then we have this second triangle, the small one that's inside of it. And if we kind of label the angles, we have S, L, and M, and then this one is N, H, and M. And what I want you to notice is that both of these triangles have angle M at the top. And wouldn't it be reasonable to say that angle M is equal to itself, right? So these triangles, even though it's kind of hidden, actually have another pair of angles that are similar, right? They have angle M. So we would say that angle N is equal to angle S, and then also angle M is equal to angle M, because obviously it's equal to itself. That is two pairs of equal angles, which is enough information to say that these triangles are similar due to angle-angle similarity. Okay, so you'll kind of see that happening in a lot of your problems where they share an angle, and because they share it, obviously that angle is equal. All right, this triangle looks like it could be a possibility for side-side-side similarity, but we just have to make sure. So we have to be careful with which sides correspond to which here. You kind of visualize this triangle being flipped upside down. So let's check. We want to make sure 202.4 over 44 is equal to 90 over 18. And we do actually have to check all the sides. We have to make sure all the sides are proportional. All right, so we're going to do some calculator work real quick. 202.4 divided by 44 is 4.6. 90 divided by 18, is 5. Okay? No bueno. This is not good. The sides are not proportional. I'm not even going to check the red because we already have the issue right here. Those are not equal. So these triangles are not similar because the ratios of their sides are not equal. So again, key concepts here. This one I am going to go through. I think it's important. Angle-angle similarity is where you have two equal angles. Side-angle side similarity is where you have two sides that are proportional, and one equal angle. And then side-side-side is where you have three sides proportional. And maybe it would be good to draw some pictures here. Okay, where you have two equal angles, two sides proportional, and one equal angle. So let's say 6 and 18, let's multiply by 3, and then 1 and 3, obviously not drawn to scale. And then we should probably include this as being important. The angle has to be in between the sides. Angle has to be between the sides. Okay, and then finally, 3 sides being proportional. Whoa. Okay. Let's say 1, 2, 3, and then 3, 6, 9. Okay, 3 sides proportional. Just an example. All right. State if the triangles below are similar and how we know. Okay. Same thing we were doing before. Looks like we have 2 sides that might be proportional. 6 and 3, 12 and 6. I don't have to set up my ratios. I actually can tell that these are just being multiplied by 2, right? 6 times 2 is 12, 3 times 2 is 6. So yes, the sides are proportional. And this is either going to be side, 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 or side, angle, side. So we're either looking for another side or an angle in between these 2 sides. We obviously don't have the other side information. There's no number there, right? So it's not going to be side, side, side. So we're hoping that the angles in between the sides are equal, okay? And actually, we do know that these are equal. These angles are across from each other between 2 intersecting lines. We learned from the previous unit, those are vertical angles, which we know are equal. So actually, yes, those angles are equal, and these triangles are similar due to side angle side similarity. All right, here we have a case of hopefully side, side, side similarity, but we might have to just check which sides go with which, okay? So this triangle has been rotated pretty wonky, but I think we've got the 25 goes with 39, and the 20 goes with 29, and the 14 goes with 21. This does not look like it's going to be good, but real quick, 25 divided by 39 is 0.64. 20 divided by 29 is not the same thing. It's like 0.689, continuing to go on. So no, these are not similar. All right, here we have no sides, so we know it's not going to be side, 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 or side, angle, side, because we don't have any sides that have been labeled with numbers. So our only option is that it's angle, angle, right? We have one set of angles that are equal, and I see just like in the first problem, we have another pair of vertical angles right here, right? Those are vertical angles. So 2 angles that are the same. This is angle, angle, similarity. So yes, these triangles are similar. All right, this could be side, angle, side. I see that we have equal angles right there. Vertical angles again, right? Vertical angles. Let's check to make sure the sides are proportionate. Is 120 divided by 12 equal to 70 divided by 8? Let's check. 120 divided by 12 is 10. 70 divided by 8 is not 10, obviously. It's 8.75. Those are not equal, so these triangles are not